Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. You are watching a special series Zero to Hero series on ESP32, ESP8266 and ESP32 Cam. Alright guys, so in this lesson I will show you some basics of ESP32 Cam. It's an introduction lesson about the ESP32 camera module, which is a small little tiny chip which comes along with the inbuilt camera. All right, so ESP32 Cam, which is of course it's very small and handy. It's a small size, low power consumption camera module based on the ESP32 chip itself, and it comes with a OV2640 camera and provides an onboard TF card, that is the SD card reader. You can also insert a SD card, micro SD card into this, and then the ESP32 Cam can widely be used in intelligent and a smart IoT applications such as wireless video transmissions, video monitoring, Wi-Fi image upload, and QR identification, quick response QR identification, and also we can also build face detection and face recognition as well. Apart from that, the most interesting aspects of ESP32 Cam is we can also build a object detection and object recognition algorithms within a tiny little chip. So that's what you're going to do, of course, along with a couple of image processing and stuff like that. So let's take a look at it from the architectural point of view, what this board does, right? So if you look at the pin drawing here, so ESP32 Cam comes with three ground pins colored in black color, right? And if you can turn it back and see, it's very clearly defined. Of course it's little confusing, little small to identify, but that's why we have this grid chart with you, where you can keep it handy or take a printout and refer to the pins like this side by side. So ESP32 comes with three ground pins colored in black color and two power pins colored with red color, which is basically 3.3 volt and 5 volt. We can use both 5 volt and 3.3 volt, but two different pins. In a later stage, I will show you some tricks how to do it. So you can also power the ESP32 Cam through the 3.3 volt for internal purpose only, for programming. That means for programming purpose only, and 5 volt pin will be used for accessing the GPIOs and connecting to sensors and stuff like that. However, many people, many experts in the industry reported errors when powering the ESP32 Cam with 3.3 volt. So I did my own R&D and research and tried to play around, and I am going to show you the best method to configure your ESP32 Cam and start loading your programs in a very easy way. So stay tuned. Now the power output pin here, if you can see, there's also the pin labeled on the silk screen as VCC. You can see it here, it's labeled as VCC. Not sure if you can see it in the video, but if you can see the chart behind me, it's colored basically with a small little yellow, right, with a yellow rectangle. Now you should not use that pin to power ESP32 Cam at all, no ways. That is an output power pin. It can either output about 5 volt or 3.3 volt, that is for the external devices. In our case, the ESP32 Cam output 3.3 volt, whether it is powered with 5 volt or 3.3 volt doesn't matter, but next to the VCC pin there are two pads, one labeled as 3.3 and other as 5. So in the camera which I am going to show you, it may not be very clear, but you can just refer to the chart which is just right behind me. Alright, then we have serial pins, right? So the serial pins are nothing but the GPIO 1 and GPIO 3 are the serial pins, that is the TX and RX, transmission and receiving respectively. So because the ESP32 Cam doesn't have a built-in programmer, right, you just cannot plug in directly to your your USB. You need to use these pins to communicate with the board and upload the code. I will show it to you in a minute how we are going to do about that, right? GPIO 0 pin determines whether the ESP32 is in a flashing mode or not, whether it's going to flash immediately or not. This GPIO is internally connected to a pull-up 10 kilo ohms resistor. Of course, we cannot see the resistor; it's just embedded inside. It's not a physical resistor what we use, right? When GPIO 0 is connected to the ground pin, the ESP32 goes into the flashing mode and you can upload the code to the board. Uploading the code is a little bit tricky. I'm going to come to that part in a minute, after I try explain the GPIO pins. Now, GPIO 0 connected to ground is basically your ESP32 cam in a flashing mode to make the ESP32 cam runs normally. You just need to disconnect the GPIO 0 from the ground once the program is loaded. These are some tricks. I will show you systematically, not to worry. This is just an introduction. Flashlight, which is a GPIO 4. So the ESP32 cam has a very bright inbuilt LED. I think that you can see it in the camera. You can see it here. There's a very bright, it's really powerful. It's bright LED that can work as a flash when taking photos or videos. So that LED is internally connected to your GPIO 4 pin internally, right? It's an internal circuit. Now, let's take a look at it, what it is. If you look closely, you should have a jumper wire. Actually, with the bare eyes, it's very difficult to see. It's a jumper. Basically, you should have a jumper wire on 3.3 volt pads. If you want to have the output of 5 volt on the VCC pin, you need to unsolder that particular connection or take a small knife or a blade, very sharp blade, and cut that connection. But remember, once you cut it, it's very difficult to connect it back for 3.3 volts. So you have to continue using it for 5 volt output. That is the VCC pin. Alright, so keep this in mind. Do not tamper the board unless until you are going to mount it permanently after loading the code. Permanently you are going to fix it in some 3D printed box or somewhere else you are going to deploy, and you are not going to touch that. Then it makes sense. If your intention is to make multiple projects, do not cut that particular pad. So now what next? So for example, if you take a look at the micro SD card pins here, so these pins are used to interface with the micro SD card when it is on operation. If you are not using the micro SD card, you can use these pins as a regular input output pins. So that is how this works. Let's take a look at the reset pin, guys. If you look at the drawing just behind me, next to the reset button, there is an onboard LED. It's a reddish yellowish kind of LED. That LED is internally connected to GPIO 33. You can use this LED to indicate that something is happening. For example, if Wi-Fi is connected, or your code has been loaded successfully, the LED is in red, or vice versa. The LED works with an inverted logic, so you can send a low signal to turn it on and a high signal to turn it off. So zeros or ones. So that is possible. Now, the most important aspect is this. So this is a small little board. This is how it looks. So basically, you have to buy this along with ESP32. Most of the vendors where you buy, it comes together, ESP32 and this particular board. So what is this board? It looks little tricky, and it comes with a small micro USB port as well, something like your Arduino Nanos and other boards. So this is called the FTDI board. So what is FTDI? FTDI stands for Future Technology Devices International Limited. It's a company which is known by its acronym called FTDI. It's a Scotland-based privately held semiconductor device company specializing in universal serial bus, your USB technology. So they are the one who manufacture this particular chip for directly programming the chip. Instead of through the USB, you have this kind of communication protocol. The best way to upload your codes into the ESP32 cam is using an FTDI programmer. Of course, there is no other option, guys. There's going to be a wiring between your FTDI pins and your ESP32 pins. So I am going to show you how to do the wiring and how to press the reset button, how to do the connection and kind of thing. So the FTDI USB to TTL serial converter module is a UART, Universal Asynchronous Receiver Transmitter board, used for TTL serial communication. It is popularly used for communication to and from a microcontroller development board such as ESP32, or there are also tons of other board. All right. Now this is a kind of very basic introduction about the ESP32 Cam, what it does and kind of thing, the pin configurations and how we are going to program it using two different board, the FTDI and the ESP32 Cam together. Without this you cannot do this. So better go ahead and pick up both together as a bundle. It generally comes as a bundle, but some vendors sell it separately. You can try it in Amazon. It just costs about 200 bucks. So go ahead and pick it up and keep it ready. So the using ESP32 Cam, we will build few interesting projects in the next upcoming lessons. For example, streaming the video on the web, on the browser. We will also do the face detection and face recognition on the web itself, by creating a web server and do the detection on the web browser. And we will also build some PIR motion detector with photo capture, when a human being is walking around, detect the face, detect the motion, send a trigger. The trigger can get into your Telegram account or your mobile phone through SMS. All those things is possible. We will try to build that together. And we will also take some photos and save it to SPIFFS. In the last 2-3 lessons, I showed you how to create a local file system within your ESP32, right? It's the same methodology. We will be using it here for ESP32 Cam and display those pictures into the web server. And of course, there are loads of more ideas. We can continue to keep building ton loads of projects using ESP32 Cam. And of course, most interesting aspect, we will also build a rover robot, which will, keep detecting the images, keep streaming the videos, and the bot will keep moving using. It's already been built, it's ready with me, and I will show it to you in the upcoming lessons. We will build it together. Alright guys, that's it for the introduction. In the next lesson, we will go ahead and hook it up and start programming. I'll show you the tricks and stay tuned. Goodbye.